Welcome to Learn Yourself. Today we are going to understand about gravitation chapter, and this is under CBSE Standard 9 syllabus. We all know gravitation very well. Few of the gravitational effects are anything which is falling and which is under free fall will go to the floor, will go to the land and will go to the earth because of the gravitation force of the earth. Our weight of the body will changes at place to place. This is also under gravitational effect. So in this chapter we are going to study how the gravitational force affect any simple motion or any free falling object, and we are going to learn some of the gravitational effect on accelerated object also. So first we are starting with centripetal force. Now what is the centripetal force? So here we are taking one example. This example is also there in the book, that we are tying one stone at the edge of the string or a thread, and then we are rotating it in a circular path, something like this. That we are standing here and we are circulating it, and stone is at the edge and we are giving a circular motion to a stone. So about that, so stone tied to a thread moves in circular path with certain speed. Its direction will change at every point. Now here the stone is there. Once it will reach here, when we are giving a circular motion to stone like this, when it is reaching over here, then we have studied this in chapter 8 and 9, that here its direction is towards this side, whereas here its direction will be here. So if we consider this direction, that it is towards in this direction and it is over this direction. So at each and every point of the circle, the direction of the stone is going to change. How much ever close you are taking a points, but then also at each and every point the direction of the stone will change. So this is one important point, that in a circular motion at each and every point the direction of the object will change. Direction will change at each and every point. Change in direction involves change in velocity or acceleration. When we are changing a direction of any moving object, it also changes its velocity or its acceleration. Alone direction we cannot change. So when we are giving a circular motion to any object, and when it is taking a circular path, at each and every point its direction will change, and since its direction will change, either of these two, velocity and acceleration, will also change. This is natural. It automatically changes along with the direction. The force that causes this acceleration and keeps the body moving along the circular path, one force has to be there, then only the body is keep on moving in circular path. So this force which causes this acceleration or keeps body moving in circular path is acting towards the center, This force is acting towards the center, and this force is called centripetal force. This force is called centripetal force. Now at any point of time when we are throwing a stone, for example a stone is here and at the same time we are leaving it from the hand. So when you are leaving the stone at any point in circular motion, so it will go across the straight line. It will go across the straight line, and this straight line will meet at only one point at a circle. This straight line is known as tangent to the circle, because this stone, whenever you are leaving from the hand, the thread you are leaving from the hand, and that will go and that will move along the straight line, and this straight line will touch to the circle at any one point. This straight line is termed as tangent to the circle. This is also called a tangent to the circle, and this will meet at circle at only one point. Now let us learn about some of the centripetal force effect. Now let us see some of the effects of centripetal force. So due to centripetal force, moon is revolving around the earth. If there was no centripetal force, then moon would have traveled in a straight line. So this is one of the reason that why moon is revolving around the earth, and that is because of the centripetal force. And if the centripetal force was not there, then it would have traveled, or its motion would have been in a straight line. Second example is when earth is falling, it is falling towards the earth, and earth is not going towards the apple. What is the reason behind that is, according to the first law of motion, apple also attracts the earth. Each object will attract another object. So basis on that, apple will also attract the earth towards itself. But why apple is going towards the earth and not earth is going towards the apple? So the reason is, but as per the second law, for a given force, acceleration is inversely proportional to the mass of the object. So as mass will be higher, acceleration will be lower, or as mass will increase, acceleration will decrease. So acceleration is inversely proportional to the mass. So if one will increase, another one will decrease. So because of this reason, apple's mass is negligible compared to earth. So earth will attract towards the apple, but that effect we cannot see because apple's mass is very less, and because of that its acceleration will increase and it will go towards the earth. Whereas earth mass is very high compared to apple, so acceleration will decrease that much. So earth will not accelerate, or earth will not go towards the apple, whereas apple will go towards the earth because its mass is negligible compared to earth. So that is the reason that mass of apple is negligible compared to earth, so earth will not move towards the apple. We can also see this effect in terms of moon revolving around the earth. That moon is revolving around the earth because of the centripetal force, and it is revolving around the earth, but earth is not revolving around the moon because moon's mass is negligible compared to earth. So earth's attraction force is higher compared to moon's attraction force. Moon also attracts earth and earth also attracts moon, but moon's effect is negligible because its mass is way more less than the earth. But we can see some of the effect of attraction of moon on the earth in terms of tides, right? Every 15 days on the day of new moon and no moon, we can see the tides in the sea and ocean. So those are the effects of the attraction of the moon. So it is also important that how much mass that object is carrying, that much its acceleration will be lesser or higher as per this relationship. Now in universe, all the objects attracts each other. So based on that, the law of gravitation has been derived. So in coming videos, we are going to discuss the law of gravitation, and that is termed as universal law of gravitation. Universal law of gravitation and its mathematical formulation, and we will derive a formula for force which attracts the object. So what is the statement of universal law of gravitation? So it says that every object in the universe attracts every other object. So each object, whether it is a small or big in size, they all will attract every other object in the universe with a force which is proportional to the product of their masses. So first is their masses, and inversely proportional to the square of the distance between them. Then distance. So it is depending upon the mass and it is depending upon the distance, that these two objects are at which distance, how far they are from each other. Let us understand from this figure. So in this figure, this is a bigger object which has mass which is in capital M. This has a mass which is in small m. Now the force which is acting between these two is directed along a line joining their centers. So here their centers are there, and this force is directed towards their centers. This line is joined towards their centers. Now they are far apart from each other with distance d. We are denoting that distance with d. So they are far from each other at distance d. So how we are calculating that distance? From the center of the first object till the center of the second object. That will consider as a distance between any two particular object. So now let us derive equation and mathematical formulation. That force which is acting in between them is, we are taking as capital F. It is proportional to, so it is directly proportional to the product of their masses. Product means multiplication of their masses. So this is capital M and this is small m. So product of their masses. So here I am going to take product. Product means multiplication of their mass. So it is in proportional to their masses and that product of their masses. So both mass multiplication we are taking it here. And inversely proportional. Inversely proportional means that term will come in denominator. Whatever term is going to come next, that will come in denominator. Then only it is inversely proportional to that. To the square of the distance between them. So distance between them is d and that to square. That to square. Now what is the meaning of it is directly proportional and inversely proportional? When any term is directly proportional, that means they both will increase simultaneously. If masses are increasing, then force will increase. But the relationship between inversely proportional quantities are one will increase, other will decrease. If the distance will increase, force will decrease. Like that. If they are very very far apart, then their attraction force will be very less. If they are closer to each other, then their attraction force will be more. It is like that. So this is a term for this law, that F is proportional to capital M small m. This is for two objects, their masses, and divided by distance square. The distance which we are calculating from the center of the two objects, from here and from here. That distance we are taking it here and that to square. Here to remove this proportionality sign, we are taking here G. So G is gravitational constant and its value is G equals to 6.673 into 10 raised to minus 11. And as a unit it will come Newton meter square divided by kg square. So this value has been found out by Henry Cavendish, and this G is known as universal gravitational constant. And to remove this proportionality sign, we have placed here G, that is universal gravitational constant, and its value is 6.673 10 raised to minus 11, and the unit will be applicable to that is Newton meter square divided by kg square. Now let us understand the importance of universal law of gravitation. So first is the force that binds that to earth. So because of that we can stand on the earth and we survive on the earth, because that force binds us to the earth and each and every object remain on the earth. Second, motion of the moon around the earth. So because of that, the motion of the moon is also that earth attracts moon, and that's why it revolves around earth. The motion of the planets around the sun, and because of this our whole solar system is existed. That because of the force of attraction of the sun, all the planets are revolving around the sun. The tides due to the moon and the sun. Tides are important part of our ecosystem and ecology. So they are important, and that is because of the moon and the sun's gravitational force. So these all are the important points, and this is the importance of gravitational force. Without that we cannot survive, and without that our ecosystem will not survive on the earth. Free fall and acceleration due to gravity and the constant G. These all topics are under CBSE Standard 9 syllabus from 10th chapter gravitation. So let us understand first what is a free fall. When I am dropping something from my hand, that is a free fall. If I am putting little bit force on that, then that is not a free fall. Free falling means apple is falling from the tree. That is a free fall. When any external force is not applicable on the object and it is falling and it is going towards the earth because of the earth's gravitational pull or force, that is termed as a free fall. When you are hitting something, when you are throwing something, that is not considered as free fall. If it is falling by its own and it is getting acceleration and it is getting a motion because of the earth gravitational force and it is hitting the ground, then it is a free fall because there is no external force applicable on that in that situation. Now let us understand the theory. Earth attracts object towards it and this is due to the gravitational force. When object falls under this force alone, when only and only gravitational pull or gravitational force is there, is applicable on the object, then we termed this fall as a free fall. And what is the condition? There should be no other external force or no other any kind of force should acting on that. No change in direction of the motion. While this fall is happening, there will be no change in the direction because it will come straight towards the down. So there is no change in direction of the motion, but there is a change in magnitude in velocity. Magnitude in velocity, that means velocity will change. When it is falling, its velocity will change. And what is the change in velocity? That is acceleration. That is acceleration. So when the object is falling due to the gravity, it will gain acceleration. It will gain acceleration. Acceleration, and that acceleration which has been attained by an object due to the gravitational force of the earth, that is known as acceleration due to gravity. Because there is no external force, only due to earth gravitational force it is getting pulled and it is accelerated. So that's why it is termed as acceleration due to gravity. Now the constant g we are using for this acceleration due to gravity term, and the unit for g is meter per second square, same as acceleration, same as acceleration unit. Now let us find out formulas to calculate the g or how to find out the g for any particular object, and we will learn how to calculate the value for constant g. Now let us find out formula for acceleration due to gravity. We know that F equals to ma, but in this formula a is acceleration and here our g is also acceleration due to gravity. So instead of a, we are writing here F equals to m into g. We have replaced a with the g because this is also acceleration, but this acceleration is due to gravity. But this is in term, this is acceleration, so we have replaced a with the g. Now in earlier formulas we have seen what is force equals to. Force equals to, we know that F equals to g capital M into small m divided by d square. This is according to the universal gravitational law. So F equals to g, the product of both of the objects' masses, and in denominator the distance square. So F equals to, this is a formula. So here this we are going to replace in this equation. This is first equation. In this first equation we are going to put this value for F. So it is going to be g into m into small m divided by d square equals to m into g. M into g. Now at both the side m is there, so we are going to cancel out this small m because both the sides small m are there, so we are going to cancel this out. So here we are going to get the value for small g, that is acceleration due to gravity, is equal to g m divided by d square. This is a formula to find out the acceleration due to gravity. Now when we are calculating this acceleration due to gravity, the earth will come in a picture because always the gravitational pull will be from the earth. So any object which is lying on the earth or which is lying near the surface of the earth is always getting attracted towards the earth. So when we are calculating the distance for the object and to the earth, because here whatever distance we have taken from the formula F, that was something like this, that from the center of the first object till the center of the second object, this distance we have calculated as d. Now here we are calculating this formula with earth's and the object's distance. So any object which is lying on the earth or which is lying near to the surface of the earth will come in its gravitational force area. So how to calculate that? So for that we are taking a radius of the earth, because whatever object is lying near the surface of the area, that distance and which is lying on the surface of the earth is, the difference between that two is very negligible. So we are always counting that as radius of the earth. Now what is the radius of the earth? For example, this is earth and this from the center till the circumference, this is going to be the radius of the earth. So any object which is lying on the earth or which is lying near to earth, it is almost similar as the radius of the earth, because the distance of the radius of the earth is very high and this much difference is very negligible. So in this formula, whenever we are taking a distance of the two objects, that from the center of the earth till the object which is lying on or near the earth's surface, that will be equals to the radius of the earth. So here we are going to replace this d with the r. So our new formula is going to be G equals to capital G m divided by r square. This r is a radius of the earth. Now this is our new formula which we are going to use it for the numerical. So this formula we need to remember. Now let us calculate the value of the G and we'll find out that what is the value for acceleration due to gravity of the earth. Here we are going to find out the value for the G. So our equation is capital G into mass of the earth divided by radius of the earth square. So here G we know that it is 6.7 into 11 Newton meter square per kg square. M is mass of the earth. This is mass of the earth. This is radius of the earth. G is universal gravitational constant and its value is this. So now let us put all this value in this equation. So we are going to get here 6.7 10 raised to 11 Newton meter square per kg square into mass of the earth. So it is 6 into 10 raised to 24 kg. In the denominator, the radius of the earth, that is 6.4 into 10 raised to 6 meter. Now when we are going to solve this, we will get here 9.8 meter per second square. So this is the value for the G. This is the value for the G, and this we are going to use in each and every numerical. Now the value of this G is different at different places on the earth. Why? Because our earth is not a perfect sphere. So at the poles the mass is concentrated here, and at North Pole and South Pole the mass is concentrated. At these places the G's value is higher compared to at the equator. So as we are going from the equator to the poles, the G's value is continuously increasing, whereas from the poles when we are coming towards the equator, the G's value is decreasing. So this changes will be there because the earth is not a perfect sphere, and here at the North Pole and South Pole G's value is more compared to the G's value at the equator. the concept of mass and weight, and we will see that how the weight will change as the place, planet and surroundings will change. Even on the earth, at the equator and at the poles, the weight will change. So we are going to discuss all these topics under CBSE Standard 9 syllabus from Chapter 10. So what is a mass? Mass is a constant quantity attached with the body. It will never change as the place will change. So mass will remain same at any place, whether you are on the earth or at any other planet. The mass will remain always same. From the previous chapters, we know that greater the mass, greater the inertia. As mass is more for the object, the inertia will be more for that object. So this is all about mass. That mass is never going to change whether the condition or the place will change. Mass will remain constant. But weight is something different from the mass. Weight will change according to the gravitational force will change. If the person is on the earth, its weight is more. But if the person is at the moon, its weight is less. Why? Because Earth's gravitational pull or force is more compared to moon. Moon's gravitational force is less, so person's weight is also less. So as the gravitational force for that place is more, the weight will be higher side. We know that F equals to ma, mass into acceleration, which will give us force. We know this also, that F equals to mg. G is acceleration due to gravity. So force equals to mass into acceleration due to gravity. The force of attraction of the earth on the object is known as weight of the object. Actually, what is a weight? Whatever force is acting on the object due to the gravitational force of the earth, that is known as weight of the object. And as per this definition, this force is a weight because the force which is acting on the object, and that is that force of attraction of the earth which is acting on the object, is known as a weight. So this force of attraction, so this force we are taking as force of attraction. So this is going to be W because that is weight. Force of attraction of the earth which is acting on the object is known as weight. So here this force we have replaced with the W, which is weight. So W equals to m into gravitational pull. So this is our new formula, that weight equals to m into g. Now what is the value for g? G is 9.8 meter per second square. What is a weight? The weight of an object is the force with which it is attracted towards the earth. It is the force by which it is attracted towards the earth. So weight equals to force acting downwards, because this gravitational force is always acting towards the earth which is at the downward. So this is force acting towards downward. It has both magnitude and direction. That magnitude means it has one specific physical quantity, and direction because it is acting towards downward. So it has a direction that it is acting towards downward. So that direction, and magnitude means it has one certain physical quantity which will tell us that this much is the weight. So weight has both magnitude and direction. Then W is proportional to m. Weight is directly proportional to object's mass, because always mass we are taking as a measure of the weight. Weight of an object is a measure of its mass. So W is proportional to m. As W will increase, mass will also increase, and vice versa. We know that W is equals to mg. So weight is depending upon the g. Weight is depending upon the g because mass will remain constant. Mass will not change from place to place. It will remain constant. Whereas g, which is acceleration due to gravity, will change from place to place, and it will different at equator also, and it will different at poles also. So as the g will change, the weight will also change. So weight is also depending upon the g. Whereas it is depending upon the mass, but mass is a constant quantity. So as g is differing, the weight will differ. Now let us understand how the weight on the moon is 1/6 time than that of on the earth. So we know this equation that W equals to m into g. W is weight, m is mass and g is acceleration due to gravity. We also know that g equals to capital G, m that is mass of the earth and r that is radius of the earth. So this is also a formula that small g equals to capital G, mass divided by r square. R is radius of the earth. So when we are putting this value, this g's value in this equation, so we will get another equation that is W weight equals to mass into capital G into m divided by r square. So this is our new formula and this we are going to use to calculate the weight of an object on the earth and weight of an object on the moon. Weight of earth is this much, weight of moon is this much, radius of the earth is this and radius of the moon is this. Now we are substituting all this value in this equation. So first we are calculating for the earth, that earth's weight and earth's radius we are substituting in this equation, and later we are taking these two values and we are substituting in this equation. By doing so we will get two different weight on the earth and weight on the moon. So here weight on the moon is this, that here we have replaced this capital M's value, that mass of the moon, that here mass of the moon is 7.36 10 raised to 22 divided by radius, that is 1.74 into 10 raised to 6, and mass small m we are keeping it as it is because later on it will eliminate, and g also we are keeping it as it is because later on it will be eliminate. So this two constant we are keeping it as it is, and we will get here 2.431 10 raised to 10 capital G into small m. Same way we are calculating weight on the earth. Here we are putting mass of the earth and radius of the earth, that square. So we will get answer 1.474 10 raised to 11 capital G into small m. Now let us take a ratio of the weight on the earth divided by weight on the moon. So we are substituting these two values in this equation, and both of this capital G and small m will get cancelled here, and we will get answer 0.165, which is almost equals to 1 divided by 6. This is decimal. When we are converting it into fractional form, it is 1 divided by 6. That means WE divided by WM equals to 1 divided by 6. Weight on earth divided by weight on moon equals to 1 divided by 6. This we can also write like this, that weight on earth equals to 6 times the weight on the moon. For example, if the weight on the earth is 1 kg, then here on the moon the weight will be 6 kg, the 6 times higher. Here weight on the moon equals to 1/6 into weight on the earth. So both the ways it is true that whatever weight, if there is a 6 kg weight is there on the moon, then it is only 1 kg weight we can see on earth. So this is the relation between earth's weight and moon's weight, and this is due to the gravitational force, as earth's gravitational force is more and moon's gravitational force is less. Thirst. So this topic is under CBSE Standard 9 syllabus from the chapter Gravitation. So what is a thrust? Net force in particular direction is a thrust. So when we are applying pressure and we are applying a force to any particular object in one specific direction, then it is known as thrust. The force per unit area, that is pressure acting on the object concerned. That means you are applying pressure. That is one kind of force you are applying to that object. So that pressure you are applying on one specific area or one specific part of object. So that unit area is under that pressure. So that is also called thrust. Now with the help of these 2 points, let us derive what is thrust. So the force acting on an object perpendicular to the surface is called thrust. For example, this is our box. We are applying pressure and that is perpendicular to that surface. Then it is known as thrust. Gravitational force is towards downward. Direction of the gravitational force is towards downwards. But here the thrust direction is perpendicular. So that means whatever pressure, whatever force we are applying on the object which is perpendicular to the surface or perpendicular to the area concerned, then it is known as thrust. For example, on a pushpin ball, we are putting a pushpin, we want to put one notice on that and we are pressing that pushpin inside the board. So the pushpin area is very small and we are applying a pressure on that top of the pushpin. So that is known as thrust because you are applying pressure directly perpendicular to that and the area concerned is the top of the pushpin. So that much area is under pressure and you are applying pressure perpendicular to the surface. So that you have applied thrust to that particular surface. Now effect of thrust depends on the area on which it acts. If the area is small, the effect is larger. If the area is large, the effect is lesser. Now, the effect of thrust depends on the area on which it acts. To understand this, let us consider a situation that we are standing on a loose sand. Loose sand means it is loose in a way that your legs will go inside. You are standing and your legs will go inside. Imagine a situation that you are on a beach. Up till ankle or above that will go inside once the water will go back. Now imagine a situation that you are lying on a beach at the same place, but you will not going inside the sand. Why? Because when you are standing, your whole weight was there on 2 feet and that area was small. When you are lying on the beach, your position is horizontal on the sand and your whole pressure, your whole body weight is divided amongst your body part. So your body will not apply that much pressure on the sand and as a result you will not go inside the sand when you are horizontally lying down on the sand. But when you are standing, when you are vertically upward and your whole body weight is on 2 of your leg, at that time you will definitely go down into the sand because your area of the pressure is small. Imagine a situation where 40 kg of weight on 2 feet, that much area, and 40 kg of pressure on whole body weight surface when you are lying down. So in that case, pressure is less when you are lying down. So you will not go down. So effect of thrust depends on the area on which it acts. For example, whatever pressure you are giving is on this much area, then whatever effect you can see, that effect will definitely less when you are applying pressure on this much area. So as the area widens, the effect of pressure will be lesser. Thrust on unit area is pressure. So this is also one definition, that thrust on unit area is pressure. So pressure equals to thrust divided by area. Pressure, what we are applying, thrust, what we are applying as a force, and divided by area. So pressure is inversely proportional to area. So as area will increase, the pressure will decrease, and area will decrease, the pressure will increase. And thrust means whatever force you are applying, that too in perpendicular direction to any particular object. So pressure equals to force in perpendicular direction divided by area. Now the unit of pressure is Newton per meter square, and based on one scientist's name and to honor one scientist, that is Blaise Pascal, to acknowledge his contribution towards the pressure, we have given the unit that is PA, which is short form of Pascal. So these two are the units for the pressure. Pressure in fluid and buoyant force. These topics are under CBSE Standard 9 syllabus from the chapter Gravitation. So fluids, what all are the fluids? The liquids are fluids because they have a property to flow. That's why we term them as fluids. Now three states of matter are there: solid, liquid and gas. They all possesses mass. They all exerts pressure. But situation is little bit different when we are talking about fluids, because fluids or liquids we are filling into a container, and when we are filling them into a container, it exerts pressure to the wall of the container. So here we are going to discuss how fluids are exerting pressure on the container or any specific object, in what all direction, and how they are exerting a force. So pressure in fluid, liquids have weight and they also exert pressure on the base and wall of the container. For example, this is our container and we have filled a liquid or a fluid till here. So it exerts a pressure to the base because it will always lie at the base. Now it also exerts pressure at the wall till how much we have filled this container. It exerts pressure in all the direction till its surface. Pressure exerted by mass of the fluid, how much ever you have filled the fluids into that, this pressure is directly proportional to the mass of the fluids, is transmitted undiminished. Undiminished means without getting zero. Diminished means almost zero or almost negligible. So it is transmitted. Transmitted means it is transferred, undiminished, without negligible value or without getting diminished, in all direction. So it exerts pressure in all the direction on the wall. Now when fluids are exerting pressure on the object or on a container of the wall, that force is termed as buoyant force, and this phenomena is known as buoyancy. So now let us understand more about buoyant force and buoyancy. To understand buoyancy, let us understand one activity. So this activity is based on an empty water bottle, empty plastic water bottle that we are trying to immerse in a water-filled container, and we will see that what will happen, and with series of this situation we will get to know and we will try to understand the buoyant force and buoyancy. So here this is one empty plastic bottle and this is one water-filled container. I am immersing this plastic bottle to deep inside the water container. I am applying certain pressure, so it will go down and it touches the bottom of the container, and then I am suddenly releasing pressure what I am applying to that of the plastic bottle. Plastic bottle is empty. I haven't filled anything into that. So it is lightweight. So to immerse into that, I have to apply some pressure. Now as soon as I am releasing my pressure, it will bounce back till the top of the water, and then it will float on the surface of the water. Now let us understand as per the buoyant force and the scientific phenomena which happened over here. Now we all know that each and every object has certain weight, and this weight is due to the gravitational force of earth acts on them. So when we are immersing this bottle and we are applying pressure to this bottle, along with that the gravitational force of earth is acting on that, so it should remain at the bottom. But when we are releasing this pressure, it jumps out and it comes back. So what is happening? That here fluids also exerts pressure on the object, and that will be in upward direction. That will be in upward direction. This is known as buoyant force. So fluids also exerts pressure on the object, and which will be in the upward direction. Now when we are immersing this bottle at the bottom, till the time I am applying pressure on that, so my pressure will be equal to the buoyant force. Whatever pressure I am applying to the bottle, and bottle will remain at the bottom because it balances the buoyant force which is applicable on the bottle, and the direction of the buoyant force will be upward. So till the time it balances, it will remain inside. As soon as I am releasing the pressure, the buoyant force will overcome the gravitational force and weight of an object, because we know that the weight of an object is very light, even though the gravitational force is act on them and the weight will be more because of the gravitational force, but the buoyant force will overcome that weight of an object, and because of that buoyant force and because of that fluid pressure which is acting upward, this bottle will comes out and it will float on the water, and it will float on the surface. Now all the objects which are remain in the fluid or on the surface of the fluid are experiencing this buoyant force, and this phenomena is known as buoyancy. So this is the reason that why a huge ship can float on the surface of the water. How much buoyant force will be applicable on the object, that is depending upon the density of the fluid. So as the fluid is more denser, the force which is buoyant force, and that will be on the higher side. So as fluid will be denser, the buoyant force measure will be higher. So let us understand this. Earth's gravitational force will be applied on the bottle in downward direction, and that is the measure of its weight. That is weight. That weight and gravitational force is acting towards the down. So weight of an object is due to the gravitational force, and gravitational force is acting towards the downward direction. But water exerts upward force on the bottle. This upward force is upthrust or buoyant force, is known as buoyant force. So whatever force exerted, we are applying pressure or the gravitational force which is applicable on the object. So force exerted, that means the water exerts force on the bottle that will be greater than that of the weight of a bottle. So weight of a bottle is a product of mass and the gravitational force. So that will be lower compared to the force exerted by the water. So here buoyant force is higher compared to the gravitational force and mass of an object. So in that circumstances and in that situation, the bottle will come out, because the force which is applying upward is higher compared to the force which is applying downward, that is lower. This is due to the gravity and due to the mass of an object which is applying downward, whereas here this is a buoyant force which will act towards the upward direction. That is greater, so that's why the bottle will bounce back towards the top of the water and it will float on the surface of the water. Upward force exerted by fluids on object is known as buoyant force, and this phenomena is known as buoyancy. And because of this reason, larger ships can sail on the water or in the ocean. Now let us understand these two reasons that why object floats or sinks when placed on the surface of the water. Here we are taking two objects. One is a cork and one is a nail. Cork's weight, we all know that it is very lightweight, whereas nail is heavy compared to cork. So when we are keeping the cork on the surface of the water, it will float. But when we are placing a nail on the surface of the water, it will sink. So what is the reason behind that? So here the density will come into picture. What is the density? Density is mass per unit volume. So density of the cork is less than that of the water. So upthrust of water in this case is larger compared to the weight of the cork. So when we are placing a cork on the surface of the water, the upward force, which is a buoyant force, it is also known as upthrust of water, will be higher in upward direction compared to the mass or the weight of the cork. So weight of the cork will pull it downward because of the gravitational force of the earth, but the upward force is higher on the side and it is pushing it upward. So here the upthrust force of the water will be greater. So that's why cork will float on the water. Now what will happen in the case of nail? The density of the iron nail is more than that of the water. So because of that, upthrust of water will be less compared to the weight of the nail. So weight of the nail is pulling it downward because of the gravitational force, but the upthrust force is pushing it upward. But here the upthrust force or the buoyant force is lesser compared to the force which is pushing it down. So that's why it will remain at the bottom of the container and it will sink, whereas the cork will float on the surface of the water. It is always depending upon the density of the object. If density of the object is more compared to water, then it will sink. And if it is less than that of the water, then it will float on the surface. Now let us understand one more example about buoyant force and try to understand that if any liquid is applying upthrust force to any object, then what will be the measure of that upthrust force? That means how much upthrust force will be applicable to any object and how to find that. So here we have taken one stone and we have attached this stone with elastic string, and we can see here this string has been elongated because of the weight of the stone. This is a container which is filled with the water. Once we are immersing this stone into the water, we can see that the elongation of the string has been reduced. Elongation of the string has been reduced because of the upthrust force of the water, which will make the weight of the stone lighter, because gravitational force is applicable towards the downward direction, but the upthrust force, which is buoyant force, is applicable towards the upward direction. That will make the difference of this two, that gravitational force and buoyant force, difference of this two will make and how much this object will become lighter. So difference of gravitational force and upthrust force will tell us that this much will be the object will become lighter when we are immersing it into the water. Now what is the meaning of this? The meaning of this is that this much upthrust force is applicable on the object, and that is how much object has replaced the mass of the fluid, or how much fluid has been replaced by the object. That much upthrust force will be applicable on that. And this idea we will get from the Archimedes principle. It says that when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Whenever we are dipping something inside, so here you can see that the surface of the water has come up because that much volume has been covered with the stone and that much water has been displaced by the stone. So how much upthrust force will be applicable to the stone? How much it has replaced the fluid, and that fluid which has been displaced by the stone, and the stone is displacing fluid. So this fluid, this liquid, the weight of this fluid, how much the stone has displaced, will be equal to the upthrust force of the water. So how much water will apply the upthrust force to any object? That once the object will dip inside partially or fully, so how much it is displacing water, the weight of that displaced mass of the water is exactly equal to the upthrust force applicable on that object. So if the object is bigger in size and it is displacing more of a water, then it is experiencing more buoyant force. And if the object is smaller and it is displacing less water, then the upthrust force applicable on that will be smaller. Now, why we are using density to check the purity of any substance? So what is a density? Density is mass per unit volume. This is a definition of density. So density of given substance under specific condition remains the same. So density of substance will never change, and under specific condition it will remain constant. Because it remains constant and it is specific for each and every substance, it will become a characteristic property of a substance. So if you want to check whether this substance is pure or not, then you can check its density. And you can refer the data which says that the purest substance density is this much, and you can compare the practical density with the theoretical value. Once both values are equal, you can say that whatever substance you have, that is purest in its form. Always we are checking density with respect to water's density. We know that water's density is 1000 kg per meter cube. So any substance density, we are taking a ratio of that substance density to that of the water's density, which is 1000 kg per meter cube, and that ratio will give us the relative density of any particular substance. So if in case there is any impurity into the substance, then it will not matches along with the theoretical value or correct value. So it will tell us and it will indicate that this substance is not in its purest form. If this value equals to the theoretical data, that means that that substance is in purest form. And based on this and Archimedes Principle's application, we have designed a lactometer. Lactometer is used to determine a purity of milk. So that is again based on Archimedes Principle, and to check purity from a density of any particular substance. Now let us understand what is relative density. Density of a substance is a different thing, but when we are talking about relative density, so relative density is a ratio of density of any substance divided by density of water. So density of water, we know that it is 1000 kg per meter cube. So for any substance density, if you know, then once you are taking a ratio of that substance density to then that of the density of the water, then this density is known as relative density. And this relative density has no unit. So relative density is equals to the density of one particular substance and divided by density of water. In coming videos, we are going to discuss many important concepts. So don't forget to subscribe, Learn Yourself. I'll see you in next video. Till then, keep learning, keep sharing.